Yes, ma'am.
For a reaction to take place, reactant molecules collide. So when we'll increase the temperature, the kinetic energy of the molecules will increase or decrease.
It will increase.
That means the speed will increase, right?
Yes.
So the number of collisions will be more or less now? When they are moving with higher speed, the number of collisions will increase or decrease?
It will increase.
They'll increase because their speed has increased now.
Yes.
So when reactant molecules collide. So when temperature increases, kinetic energy increases, speed increases, and number of collisions increases.
Increase.
And when number of collisions increases, the rate of reaction increases.
Increases.
And you know that rate of reaction is directly proportional to rate constant. The expression was like
Yes.
this: R
Yes.
is equal to K into concentration raised to the power N, right?
Yes.
So if the rate of reaction is increasing, rate constant will also increase because it is directly proportional, right?
Yes. Yes.
So this is the basic of effect of temperature. So it is observed that when we increase the temperature by 10 degrees Celsius, the rate constant is doubled. Okay.
Yes, ma'am.
So it has been observed that for a chemical reaction, with rise in temperature by 10 degrees Celsius, the rate constant is nearly doubled. That means the rate of reaction is also doubled because both of them are directly proportional. Okay, so this basic should be clear to you that rate of reaction will increase with increase in the number of collisions, and on increasing the temperature, speed of the particles increases or the kinetic energy of the molecules increases, and that will lead to more collisions and more will be the rate of reaction. And this is an observation that with 10-degree rise in temperature, the rate constant is nearly doubled. Okay.
Okay, ma'am.
Now we have to talk about a relationship between rate constant and temperature because we are studying the effect of temperature on rate of reaction. So we have to study a relationship. So that equation is called as Arrhenius equation because it was given by Arrhenius. Do you remember the equation? It is K is equal to A e to the power minus EA by RT. So this gives the relationship between rate constant and temperature. So K is rate constant, okay?
Yes.
What is T?
Temperature.
Yes. What is R?
Rate. No.
Temperature you have to take in Kelvin.
Yes.
R is gas constant. What is the value of gas constant? Do you remember that constant? 8.314 joule per mole per Kelvin, right?
Yes, ma'am.
Now, A is a factor which is called as Arrhenius factor, or it is called as frequency factors. These names you have to remember.
Okay, ma'am.
And you can observe that this A factor is coming before this exponential term. This E is exponential constant. So
Okay.
A is coming before it. That's why the name is pre-exponential factor. So these are the three names of A: Arrhenius factor, frequency factor, and pre-exponential
factor.
Okay. What is this EA? Do you know EA? EA is activation energy.
Okay.
And the unit of activation energy is joule per mole. Or you can change it into kilojoule per mole. Are these terms clear to you?
Yes, ma'am.
Okay. Now, the value of Arrhenius factor and activation energy. They are characteristics of a reaction. They are characteristics of a reaction. They are fixed
Yes.
for every reaction.
Okay.
And they are collectively sometimes called as Arrhenius parameters because the equation is Arrhenius equation and these two parameters are involved in it. So they are collectively called as Arrhenius parameters.
Okay.
Now the equation is K is equal to A e to the power minus EA by RT. Now if we take ln both sides, what will we get? If we take ln K, on the
In
right hand side also we take ln K. These two terms are in multiplication. A into minus EA by RT. These are in
A. Yes.
multiplication. And you know that ln A into B is equal to
A plus B.
ln A plus ln B.
A B.
So we can write ln K is equal to ln A plus ln.
Ln E raised to the power E.
Now you have to remember this property that ln A to the power B is equal to B ln A. The power comes in front. So it
Okay.
will become ln K is equal to ln A and this power minus EA by RT will come in front and the remaining is ln E.
Ln
And
E.
the value of ln E is 1.
1. Yes.
So the equation will become ln
K
K
is
is equal
equals
to
to ln A minus E by RT 1.
yes. ln E is 1, so EA by RT into 1 will become EA by RT. Now we
Yes.
have to plot a graph between ln K, ln K and 1 by T. Now tell me, how will the graph? Tell me the shape of the graph. How will you get the graph?
It's gonna be straight line.
Yes. What will be the slope?
From a
See, on the y-axis you have ln K
yes,
and on the x-axis you are having 1 by T. So this
1
is your
by
x and this will be your intercept. So the equation
yes,
is y is equal to mx plus c,
yeah,
straight line equation. The
yes.
slope is positive or negative?
It's positive.
No, it's negative. M,
How?
it is minus
Oh
EA
yes,
by
yes,
R.
it's negative, negative.
It will be negative. The value of intercept, this point, this is ln A and the slope M is equal to minus EA by R. Okay.
Yes,
So if we convert this equation in log now, you know that when we have to change ln into log, we have to multiply it by 2.303.
yes,
Okay. So we can write 2.303 log K. We are changing ln A into log, so we'll write 2.303 log A, right?
yes, ma'am.
Okay, and minus EA by R. Now, if you divide the whole equation by 2.303, what will you get? You have to divide the whole equation, both sides, by 2.303. It will be log k, because
Log
2.303 will be get cancelled. Here it will become log a minus EA by 2.303 RT. Is it clear?
yes, ma'am.
You just had to divide. Now, if we plot a graph again between log k, in this chapter, log graphs are very important. So log k and 1 by t. Again, you are getting the same equation, y is equal to c plus mx, because on the y-axis we have log k and on the x-axis we have 1 by t.
1 by t, yes.
And this one is your intercept. This one we have. So again, it will be a negative slope.
Negative sign.
And intercept is log a. And the slope is m is equal to minus EA by 2.303 R. Is it clear?
Yes, ma'am.
Now, if you observe this equation, this one, if we increase temperature, this whole term will increase or decrease? Ignore the negative sign. If you increase temperature, this whole term will increase or decrease? Okay, tell me, if you increase this temperature, the denominator will increase or decrease?
It will, okay, wait. The denominator,
Yes.
wait,
It will increase because you
it
are
will
increasing the
increase.
temperature, right?
Yes,
And
yes,
when denominator increases, fractional value decreases, right?
yes, yes,
Fraction decreases. So this whole value is getting decreased. That means the negative value minus EA by 2.303 RT, the whole negative value is decreasing.
yes,
And if the negative value is decreasing, that means this whole term will increase, the right hand part, log A minus 2.303 RT,
0.3 will,
because
yes,
lesser amount is getting subtracted now, lesser value is getting subtracted because negative value is decreasing. So
decreasing.
if earlier 5 minus 4 was getting subtracted, now 5 minus 3 will get subtracted because the negative value is decreasing. So
Yes,
the overall answer on the right hand side will increase, right?
yes, ma'am.
That means the value of log k will increase.
Increase.
Hence, we can say that k will increase.
Okay.
So you have to remember that on increasing temperature, the value of rate constant will increase and the rate of reaction will
Action will
increase.
increase.
Is it clear to you?
Yes, ma'am. Can you just scroll up? I'll just write. I'll note points.
Have you done?
Yes, ma'am.
Now we have to talk about temperature coefficient. Have you heard this term before?
No. Wait,
You haven't heard or you have forgot.
I have forgotten. Yes.
So temperature coefficient, it is the ratio of rate constants. It is the ratio of rate constant. That means it is the ratio of K at two different temperatures. At two different temperatures with difference of 10 degree. So temperatures are having a difference of 10 degrees Celsius and you have to take the ratio of rate constant. So we can write temperature coefficient is equal to rate constant at T plus 10 degrees Celsius and rate constant at T temperature. So we have taken two temperatures. One is T degrees Celsius and the other one is T plus 10 degrees Celsius.
10 degrees Celsius.
And you can see that there's a difference of 10 degrees Celsius between both the temperatures.
Yes.
And I just now told you that with increase in temperature, rate constant increases.
Increases.
So at two different temperatures, there will be different values of rate constant. So temperature coefficient is the ratio of rate constant at two different
Two
temperatures.
different temperatures.
Now we'll derive a relationship between rate constants at two different temperatures. So suppose at T1 temperature, the rate constant is K1 and at T2 temperature,
Yes, ma'am.
the rate constant is K2. And we are talking about a reaction. So we saw the equation that log K is equal to log A minus EA by 2.303 RT. This is the equation. So for the first temperature, it will be log K1 is equal to log A minus EA by 2.303 RT1. Is it okay?
Yes, ma'am.
Because I told you that A and EA,
Yes.
they are characteristics of a reaction. So A and EA will remain same for both the temperatures. And now
Yes.
for the temperature, it will be log K2 is equal to log A minus EA by 2.303 RT2. So this is your equation number 1 and this is your equation number 2.
2.
If we subtract the two equations, 2 minus 1.
1. Okay.
So it will become log K2
Log
minus
A.
K1.
Yes.
And the right hand side it will become log A
K2.
minus EA by 2.303 RT,
T.
RT2 minus log A
A
minus
minus ER.
EA by 2.3,
2.303 R. T1.
right? Now when you open the bracket, log A and log A will get cancelled, log A minus log A.
Yes.
And log A minus log B is equal to log A upon B. This you have to
Yes.
remember. That log A minus log B is equal to log A upon B. So now, if you open the bracket on the right hand side, it will become minus EA by 2.303 RT1 and minus minus will become plus now. So the second term will be positive sign EA upon 2.303 RT1. This is negative T2 and T1 is positive. Is it clear?
Yes, ma'am.
Now if you rearrange this, so log K2 by K1 and if you take EA by 2.303 R, you're taking it common. So in the bracket inside, it will become 1 by T1 because 1 by T1 is positive and 1
Yes.
by T2 is negative.
Negative.
So this is an important relationship between rate constants at two different temperatures.
Okay.
Okay, and in this you have to take the temperatures in Kelvin. Is it clear?
Yes, yes.
Okay. Now the next one is catalyst. The next. So what is a catalyst?
Um, Catalyst.
It is a substance which increases the rate of reaction. Remember?
Yes, yes, I remember.
So the substance which increases the rate of reaction, that is called as a catalyst.
Catalyst.
And it doesn't get consumed in the reaction.
Yes.
It does not. It participates in the reaction, but it doesn't get consumed. We get it back
Yes.
after the end of the reaction. And now there are two types of catalyst. The catalyst may increase the rate of reaction and it may also decrease the rate of reaction.
Decrease the rate of
So
reaction.
if it increases the rate of reaction, we call it as positive catalyst. And if it decreases the rate of reaction, it is called as a negative catalyst.
Negative.
Okay. So
Okay.
there are both types of catalyst. And the negative catalyst is also called as inhibitor because it is reducing or decreasing the rate of reaction.
Okay.
So catalyst takes part in the reaction, but it doesn't get consumed. What is the function of catalyst now? We got to know that it increases the rate of reaction, but how does it increases?
Um,
Yes, tell me.
Function means like
What role is it playing? Like it is increasing the rate of reaction, but what
yes.
it is actually doing that because of that the reaction rate is getting increased. So I'll explain you. Now see, you have reactants. This much energy is of the reactant. So it is represented by ER.
Yes.
And this is the energy of products. And now you must have studied this curve, right? This type of
Yes.
curve. So reactants are getting transformed into products.
Products.
There is an energy barrier. The reactants has to cross this energy barrier. They have to attain this much energy and then they'll get transformed into product. So this, the topmost energy peak, this is called as activated complex. Remember?
Yes. Yes. Activated complex.
Or it was called as transition state. So if this is the path of the reaction without the catalyst, so the catalyst decreases the activation energy. See, this much is the reactant energy. And
Yeah.
for the reaction to take place, the reactant should possess this much energy, right? But it is
Yes.
having only this much. So it needs this much amount of extra energy, right?
Yes, ma'am.
So the extra energy required by the reactant molecules to get transformed into products, that is called as activation energy. Okay.
Yes, ma'am.
So this activation energy is this much, the extra amount, and it is represented by EA. We are talking about this EA, right? Activation energy. So it is the extra energy. And the total energy which should be possessed by the reactant molecule, this total energy. This is called as threshold energy.
Threshold energy. Yes.
So the relationship can become threshold energy is equal to activation energy
Activation energy.
plus energy of reactants, right?
Yes. Energy.
Because we are seeing that energy of reactants plus this much amount of extra energy, that will make the total threshold energy.
Threshold energy.
Okay. Now tell me, in this reaction, which one is having more energy? Product or reactant? Which is greater?
Product.
Yes. That means reactants have lesser energy and products have more
Product
energy. That
more
means that
energy.
products have absorbed energy, right?
Yes, ma'am.
And the reactions in which energy is absorbed is called as an endothermic reaction.
Endothermic reaction. Yes.
Now the catalyst provides an alternate pathway to the reaction by reducing the activation energy. Now this reaction is needing this much amount of activation energy. Now if we
Yes.
add a catalyst now, so the catalyst will give an alternate path to the reaction by decreasing the activation energy. So now you can see that the reaction now needs this much energy. So the activation energy has been reduced.
Yes.
Can you notice? Earlier it was this much, but now it
Yes.
is
Yes.
only this much. So catalyst reduces the activation energy by providing an alternate path to the reaction.
To the reaction. Okay. Yes, ma'am.
So this is the role of catalyst, that catalyst provides an alternate path to the reaction by decreasing or reducing the activation energy. So this you should remember.
Okay, ma'am.
And I told you that this is the energy barrier. This much energy has to be attained by the reactor. So it has lowered the energy barrier, right?
Yes.
So if the activation energy is low, if lesser amount of energy is required by the reaction, rate of reaction will be slow or fast. If less amount of energy is required by the
Slow.
reaction. No, if less amount of energy is required by the reactants, then the reaction will be fast
Okay.
because they can easily get low energy. But if the activation energy is higher, if they need large amount of energy, extra energy, then the reaction will be slow.
Slow.
Okay. So lower the activation energy, faster will be the reaction because activation energy is the extra energy required.
Okay.
Do you know the difference between spontaneous reactions and non-spontaneous reactions?
Yes. Yes.
Yes, please tell me.
Wait. Just a spontaneous reaction.
I'll tell you. The reaction which proceeds on its own, which can happen naturally.
Yes.
Like in waterfall, water is flowing down. This happens on its own, right? So this
Yes.
one is a spontaneous reaction. But if we talk about a motor pump, you know that motor pump lifts water upwards, right?
Yes.
And for this, we have to provide external energy. So the reactions which do not proceed on their own, which need an external factor to proceed, that is called as non-spontaneous.
Non-spontaneous. Okay.
So catalyst always catalyzes spontaneous reactions. Okay, the reactions which can proceed on their own, only that can be catalyzed by a catalyst. Only the speed of reaction of these reactions can be increased. But for a non-spontaneous reaction, it can't catalyze. Okay,
Okay.
so this you should remember. You have heard about equilibrium constant.
Yes.
Okay, so a catalyst does not change equilibrium constant. The value remains the same.
Okay.
It just helps to attain the equilibrium faster. The reaction reaches the equilibrium point faster. Okay, so this is the rule. It helps in attaining equilibrium faster. Okay, so this is the role of. Now you know that a reversible reaction Reactants are getting transformed into products and products are getting transformed into
Into
reactants.
reactants, yes.
That means the reaction is taking place in both directions, forward direction as well as the backward direction.
Backward directions, yes.
So the reaction, so the catalyst will increase the rate of forward direction and the backward direction by the same extent, by the same amount. Okay. The
Yes.
equilibrium will remain the same, but the time required to achieve the equilibrium, that will decrease, so that the equilibrium is achieved faster. Okay, so this is the role of the catalyst.
Yes.
And for the graph, you should be very clear that if this is the original path of reaction, the catalyst will come and decrease the activation energy by providing an alternate path. So if earlier this much amount of extra energy was needed, this was the activation energy without the catalyst, this red one.
Yes.
If we added the catalyst, the activation energy will decrease, and now the activation energy will be this blue one. So you can see that catalyst reduces the activation energy by providing an alternate path. And if the activation energy is low, rate of reaction will increase. So hence we say that catalyst increases the rate of reaction. Have you understood?
Yes, ma'am.
Okay. You must have learned about delta G in class 11.
Yes.
Gives free energy.
Gives energy.
Yes, yes. So you should remember that catalyst does not change the Gibbs free energy of a reaction. The value remains the same.
Same, okay.
This you should know. So these were the points related to catalyst.
Catalyst.
Now I'm giving you few questions to solve. I'm giving you 10 minutes and you have to solve those questions. Okay. So
Okay.
open your book, exercises.
Okay. Question number?
Question number 26.
Okay.
So you can see that it is a decomposition of hydrocarbon. This is the reaction and it follows the equation. So equation is given, right? K is equal to 4.5 and so on. And you have to calculate EA. What is EA? We have just discussed.
Yes, yes, one minute.
EA is activation energy.
Okay, so yeah, okay.
So you have to calculate activation energy.
Okay, fine.
This one we'll try. Next is question number 27.
27.
So in that also the rate constant is given. An equation is given in terms of log K. We have discussed this type of equation, right?
Yes, yes.
So in this reaction, in this question, you have to calculate again the activation energy for the reaction. Okay.
Okay, ma'am.
Now, if we talk about question number 30, you have to solve that. In question number 30, it is written the rate of a reaction quadruples. Quadruple means it has become 4 times.
Okay.
So if the rate of reaction is becoming 4 times, the rate constant will also become 4 times, right?
Yes.
Because the rate constant is directly proportional to the rate of the reaction.
Rate of the reaction, yes.
So this you should remember. What else can we do? Question number 29 also you try. All
Okay.
these are good questions. So how much time do you need for this? 10 minutes are enough?
Okay, fine.
So I'll ask you in 10 minutes.
Okay.
Have you done, Rufia?
Yes, I have done 26 and 30.
What are you doing now? Does it open?
Yeah, I'm actually now doing 27.
Do you need more time?
Yeah, yeah, I can do 27.
So how much time do you need?
Just 5 minutes more.
Okay, let's discuss.
Okay, ma'am.
So in question number 26, it is k is
Yes,
equal to a. You must have equated this equation. Minus.
yes. Yeah, this question is easy.
Yes, so you must have got that minus EA by
See, RT
RT.
is
Okay.
equals to minus 2 to 80,000
Yes,
Kelvin by
28,000
T.
Kelvin by T. Now you must have cancelled temperature,
Yes,
and then minus minus will get
minus
cancelled,
cancelled
and then activation energy will become
to
28,000
80,000.
into R, and K is also there.
Yes,
And the value of R is
8.314
joule
joule
per mole per
per.
Kelvin, and 1 Kelvin is already there. So Kelvin,
Yes,
Kelvin inverse will get cancelled, and what is the answer?
the answer is 232.7 and 9, something like that.
So this is in kilojoule per mole, right?
Yes.
So this one was easy. Next. Did you try to question number 27?
Yeah, I did. I did on comparing minus 8 by 2.303 RT is equals to minus
Yes, so the equation can be
1.5.
log A
Yeah,
is
into
equal
T.
to log A minus EA by 2.303 RT, right? This one.
Yes.
Now, if we compare, then you must have got that log A
Yeah,
is equal
minus.
to 14.34, right?
Yes.
By equating. And the value of EA by R minus EA by 2.303 R
2.303 RT
is equal to,
was 2 minus 1.24 into 10 raised to 4 Kelvin by T.
now
And
again the
then we
temperature will get
multiply
cancelled. Yes. So
1.24 into 10 raised to 4 into 2.314 into 2.303.
and minus sign will get cancelled
Yes.
into 2.303 into 8.314. What is the answer?
The answer I got is 103.92 into 2.303.
100 and
3.92.
no,
103.92.
no, it's not correct. 1.25 into 2.303 into 8.314. It is
Oh,
23.93 into 10 to the power 4 joule per mole. So this is your activation energy.
okay.
Then in the second part, it was also saying calculate activation energy for this reaction. So for this reaction, we have calculated. And at what temperature will be its half-life? 256 minutes. So this is the first order reaction it is mentioned. And
Yes,
what is the formula of T half?
T half. It's 0.693
By K.
K. So
So
the
they are
K is
saying that half,
256.
yes.
No, yes. Minutes.
So it will be 0.693 by T half. K will be equal to this. And T half is given as 256 minutes.
256 minutes, yes.
So we'll convert that into seconds. So 256 into 60. You'll get the answer of rate constant here. Okay. And
Okay.
what will be the unit of rate constant for first order reaction?
It's second inverse.
Yes, it's second inverse.
Okay.
And then you have to calculate the temperature at
The
which,
log K.
yes, again you'll use log K is equal to log A
14.34.
minus E by 2.303 RT.
Okay.
So you got the value of log K. From K, you'll get from here. So you'll substitute that value here. And the reaction is same. So the value
Yes.
of log A will be 14.34 only.
3, 4, yes. Minus
1.25.
25 into 10 raised to 4 Kelvin by T.
Yes. So now you have to calculate the value of temperature.
Temperature.
Okay.
Okay.
So this will you'll try as homework. Right.
Okay.
Now question number 28.
Question number 28, I did not do it.
Okay.
Wait, question number 28 or 29?
20. I gave you 29.
Yeah, you gave me 29.
Okay. First you try question number 28. Then we'll jump into 29.
Okay.
Have you done?
No, just 1 minute.
Okay.
Yes, ma'am.
Okay. It is the decomposition of A into a product, right?
Yes.
And the value of rate constant is given. So we can say that K1 is equal to 4.5 into 10 to the power 3 per second. And,
Yes. And K2 is 4.5 into 10 raised to 3 seconds.
and temperature is given in degrees Celsius.
Yes.
Have you converted the temperature into Kelvin? Yes or no?
No, Kelvin? No.
I told you to take the temperature in Kelvin. So
Oh,
convert 10 degrees Celsius into Kelvin. How much did you got?
no, just 1 minute. $283.
Yes, it is 10 plus 273. So whenever you have to change the temperature from Celsius to Kelvin, you have to add 273. So you have the value of two rate constant at different temperatures. You have got one temperature and the one temperature is
Yeah,
missing.
T2 we have to find.
Yes, and the activation energy is given. So you convert into joule per mole. It is given in kilojoule. So you have to convert that into joule per mole by multiplying it with 1000.
Okay.
Now, which equation will you use?
Log K2 by K1 is equals to EA by 2.303 R. And then it's T2 minus T1. We have to use that equation, right? T2.
T2 minus T1 upon T1 into T2.
T1 by T2.
So if you substitute the values,
Log 1.5 into 10 raised to 4 by 4.5 into 10 raised to 3 is equals to 60 into 1000 by 2.303 into 8.314.
there you got T2 minus
Minus
280.
283 by 283 T2.
Yes, did you solve?
No.
Okay. So if you see here, you know that 15 threes is 45
Yeah,
times
just 1 minute, I'm doing it.
and it will get cancelled.
Log 10 by 3
Yes, you'll get log 10 by,
is equals to 6000 by,
and this you have to solve.
it's 19.14.
It is 60,000 by something. 60.
6000.
Are you using calculator?
No. It's 60,000.
60,000 divided by 2.303 divided by 8.314, right?
Yes.
So you'll get the value 3133.62. Okay. And
Okay.
along with that, you have T2 minus 283 upon 283 T2. So you can divide this 3133 by
Okay.
283, right?
Yes.
So you'll get somewhere 11.07
07.
into T2 minus 283. Okay, so the right side is easy to solve, just it is involving calculations. Now this log
Okay.
10 by 3 can be written as log 10 minus log 3. Yes or no?
Yes. Log 10 minus log 3.
Yes. So log 10 value is 1. Log 10 is 1.
Yes.
And the value of log 3, do you remember?
No.
It is 4.77.
Okay.
So if you solve this, so 1 minus 0.477, what is the answer?
I'm doing it.
Okay. Did you got 1 minus 0.477?
Yes.
What is the answer?
I got 3.77.
1 minus 0.77.
Oh, it's 0.477. Okay, I did 4.77. Just 1 minute. I'm so sorry.
Do it
It's
fast.
0.523.
Yes. And then you'll multiply this T2 there. So it will become 0.523 T2.
T2.
And then you'll multiply 11.07 with this, both the terms.
Yes.
11.07
7.
T2
T2
minus
minus
11.07 into 283.
283.
Now can you solve this?
Okay.
So you can do it as homework. Will you be able
Okay.
to do this?
Yes, I'll do it.
Now question number 29. So it's given that in question number 29. Were you able to solve it?
No.
Okay. So
But
time
I did
required
try.
for 10% completion of a first order reaction and the temperature is 298 Kelvin. It is equal to time required for 25% completion at 308 Kelvin. Okay. So there is a first order reaction and it has been taking place at two different temperatures.
Yes.
Do you remember the formula integrated rate equation for first order reaction?
Yes, I remember.
Tell me.
Even by R not by
It is K is equal to 2.303
3.
by T log
Log R not. Yeah.
your
A.
R naught or R. A naught.
Yes. A not by A.
Now, you have to calculate time for 10%. So we can rearrange the formula.
Yes.
Here we'll get T and this side will get K.
K.
So it will be T and K. So T 10% we are calculating first. So it will be 2.303 by K
Okay.
log, if the initial concentration is 100 and the reaction has been completed only 10%.
So 90 by 100.
So 100 by 90.
Okay.
Fine. So here you get 2.303 by K log 10 by 9, right?
Yeah, 10 by 9.
Now, again, if I calculate 25%, T25%, it will become
Yeah, so
2.303.
2.303 by K log 100 by 75.
Yes. And you know that 25 foci is 100, 25 3 is 75.
Yes, 3 by
So we
4.
can write like 2.303 by K
K log
log
3 by
4
4.
by 3.
Okay, 4 by 3.
Yes. And you know that these two rate constant values are different because this is the K at 298 Kelvin and this is the K at 308 Kelvin.
Okay.
And we know that with increase in temperature, rate constant also increases, right?
Yes.
So in the question, it's given that the time required for 10% completion is equal to time required for 25% completion.
25%.
So can we equate the both terms?
Yes. Yes, right?
Yes. So in the left hand side, we're having T 10% is equal to T 25%.
Yes.
So 2.303 by K 298 Kelvin.
Yes.
This is the rate constant at 298 Kelvin.
98 Kelvin.
And in multiplication, along with that, we have log 10 by 9, right?
Yes.
So log 10 by 9 can be written as log 10 minus log 9.
Log 9. Log 10 is 1 minus 9. Log 9.
So we can write log 10 minus log 9.
9.
And on the right hand side, we'll have 2.303 by K at 308 Kelvin.
Log 4 minus log 3.
Yes, log 4 minus log. So 2.303 will get cancelled.
Yes.
Now, if you rearrange, if you take here temperature rate constant at 308 Kelvin upon rate constant at 298 Kelvin. And on the right side, you'll get in the numerator log 4 minus log 3. And in the denominator, this can
Divided by log 10 minus log 9.
yes.
Okay.
So log 4 is 0.60. Do you remember the value of log 2?
Log 2.
Yes, it is 0.301. And log 4 is just double of that. It is 0.602.
Okay. Log 3 0.477.
Yes.
Divided by 1 minus log 9.
Log 3 is 0.477 and log 9 is 0.954. Because log 9 can be written as log 3 square, right?
Yes.
And power will come in front, so it will become 2 log 3. So
2
if
log
we multiply 0.477 into 2, we'll get 0.954.
Okay.
Now you can solve the right hand side value.
Yes.
Let's do it. What did you get in the numerator?
I got 0.1 2, 5.
Right. And in the denominator,
I got 0.045.
4, 6.
Okay, yeah.
And if you
Yes,
simplify
yes,
this,
sir.
it will become 125 upon 46. So it's nearly equal to 2.7 something.
Okay, 2.7. Yes,
So
2.7.
we have got the value of K 2308 by K 298. So we can also write it as K2 by K1. Okay. We have taken 308 as 2, K2 and K298 as K1. Okay.
K1, yes.
And now you had to calculate.
Log
Now,
K2 by K1?
yes, you'll use that equation and solve for the activation energy. So
Okay.
log K2 by K1 is equal to EA
EA
by
by 2.303 R.
T2 minus T1 upon T1 into T2. So you have got this value K2 by K1. So you'll put here
Yes.
log 2.71. We'll substitute the value of R. We'll substitute the value of temperatures and then you'll get the answer for activation energy. Understood?
Okay. Yes, yes.
Now, what about question number 30?
Yes, question number 30 I read.
So what did you get as the answer?
I got 52.8, something like that.
So
52.8.
have you understood that
Yes,
K2 by
it's 4
K1
times. Yeah,
4 because the rate of reaction is quadrupled.
or
That means it is becoming 4 times. So the
4
ratio will
times.
become 4.
4.
And log 4, did you remember the value of log 4?
Yeah, I checked it.
See, log 4 you can remember like this because log 4 can be written as log 2 square and then power will come in front. So it will become 2 log 2. And log
Okay.
2 is 0.301. So you'll get the answer 0.602. At least you can learn the values of log 2 and log 3 and log 10. So log 2 is 0.301, log 3 is 0.477 and log 10 is 1.
Okay.
So this much you can learn and then you can find out the values for 4, 8 or 9.
Yes.
And
Okay.
then you can rearrange. Fine. So one short topic is left, that is the collision theory. I told you that for the reaction to take place, reactant molecules have to collide, right?
Yes.
So if we are talking about a simple reaction, H2 plus I2 forms 2HI. So the reactant molecules, they have to collide with each other. So H2, 2 atoms are there, I2, 2 atoms are there.
2 atoms.
Then they have to collide like this in a proper orientation. And
Yes.
they should have sufficient energy to cross this barrier. And this
Okay.
extra energy required was called as activation energy, right?
Yes, ma'am.
So first condition is that they should have the activation energy. And second condition of the collision is proper orientation.
Okay.
That means the molecules should collide head on. Head on collision should be there. If the molecules are colliding like this, then proper reaction won't take place because these two are not participating. These two are not colliding, right?
Yes.
Or if they are colliding in this manner, then also it's not effective.
Yes.
The orientation should be proper. These two conditions are necessary for an effective collision.
Okay.
You know that gas molecules have a lot of space between them. They are always in random motion. So they move here and there rapidly and they are colliding with each other. The molecules are colliding with each other. And because of these collisions, reaction will take place. But every collision does not result into product formation. And the
Okay.
collisions which lead to product formation, those are called as effective collisions. And the collisions which do not lead to product formation, they will be called as ineffective collisions. Okay. So all the
Okay.
collisions are not effective. The collisions which will satisfy these two conditions. One of the activation energy, that means they should have the amount of energy required to cross the barrier. And second one, their orientation should be proper. Then only the product formation will take place. Okay.
Okay.
So the chapter is over. Now,
Okay.
your homework is to revise the whole chapter.
Okay.
Will you do it?
Yes. Inshallah.
Okay, good. And you have to also revise the previous one, that is electrochemistry.
Electrochemistry. Yes.
So in the next class, first we'll discuss whatever you will be having the doubts, and then we'll start with the solutions chapter.